Okay, good morning everybody. How y'all doing? Day 3 at the Uptime Institute. Hanging in there. So again, my name is Jim Elliott and I run the memory marketing organization at Samsung Semiconductor. Not to be confused with the cell phone or the TV set divisions. Completely different part of the Samsung organization. So I have a quick presentation today. My agenda consists of 3 main parts. First, I'm going to talk about some of the worldwide IT trends and their impact. Second is I want to give a quick recap of the server roundup. And then third, let's talk a little bit about solutions and a call to action as well. I'd like to start my presentations by talking about this portable device and mobile internet boom. This is a slide from Mary Meeker that some of you may be familiar with. It talks about every decade there's a 10x increase in the number of connected devices. So look at the y-axis, it's logarithmic. So we went from a PC era of, say, 100 million units to a wired internet to a mobile internet, 10 billion connected devices over the next 10 years. Now we're talking about the Internet of Devices. I think there was a Cisco commercial last night that talked about the Internet of Everything, right? So that's now you're connecting machines to machines. That's the next 10x increase in connected devices. Think about the infrastructure requirements on the back end to connect all these devices. Look at the transition from the PC to the mobile era. PC in blue down at the bottom you can see is being dwarfed by smartphone as well as tablet, including a converged device. Where does the tablet end and the PC laptop begin? Again, you can see that the crossover point has happened a couple of years ago in terms of smartphone for PC, and now we're looking at an area where tablets could potentially outship PCs here in the near future as well. This is an interesting concept as well. Look at social networking and the impact that that has on IT as well. Think of this as the glue that connects all these different devices. You know, look at Facebook, they've got 1 billion users now. One of the challenges of showing this slide is that the data becomes obsolete the minute that we can research it on the internet. For example, I think the gentleman from Twitter pointed out yesterday they are now up to 400 million tweets per day. 33,000 per second is the record. So I know you guys are a pretty technologically savvy audience. I imagine most people in the room have a Facebook account. Most people have probably even logged in sometime today. Some of you might even be on Facebook right now. What's interesting is if you look at the 18 to 34-year-old demographic, about 30% of people check Facebook before they get out of bed in the morning. So that is the embodiment of this mobile internet and the impact that social networking has on IT. Think again about the infrastructure that's needed to connect all these users. So as a result, look at the server as well as the storage growth rates over the next 5 years. Server perhaps as much as 10% per year. Storage about almost 50% per year CAGR. Again, think about that infrastructure required. More video now uploaded to YouTube in 1 month than the major 3 US TV networks produced in 60 years. So there's a lot of back-end infrastructure required to move this data around efficiently. What's happening now is data center power is becoming mainstream. There was a New York Times article recently that came out talking about, front page right here, power pollution in the internet. A single data center can use more power than a medium-sized town. So again, this is becoming in the mainstream media, moving beyond just the technical press. Look at the growth, more than 3 million data centers worldwide, and this number continues to grow with this explosion of mobile devices as well as the connectivity requirements. Worldwide data centers use about 30 billion watts of electricity. This is the equivalent of about 30 nuclear power plants. The US accounts for almost roughly 1/3 of this activity. And you look at this, it's about 2.2% of the total US electricity footprint, and maybe 1.5% of the worldwide energy footprint. So this is becoming a major situation here moving forward. So we talked a little bit, I think, about comatose servers yesterday with the server roundup, and we're very excited to be here to sponsor that. We have kind of coined the phrase zombie servers as well, working with Dr. Kumi on that. Look at the paradigm here, or this continuum between an inefficient data center and an efficient data center. Inefficient data centers, of course, a 10-year refresh, very low virtualization, high maintenance, versus efficient data centers, maybe a 3-year refresh, for example. There's a great case study here that I want to reference where there was a company with servers installed in 2007 or earlier, 4% of the performance capability, yet they were consuming about 60% of the energy in that data center installation. So think about these zombie servers, right? They're power hungry, they're inefficient. These comatose servers need to really be decommissioned and unplugged. Look at now that even the Energy Star, the EPA, is paying attention to this space. They've come out with a new server or data center Energy Star spec, version 2. They've taken the watts per gigabyte from 2 watts down to 0.7 watts per gigabyte for the memory requirements. And then according to some estimates, the zombie or comatose servers could be as high as 10 to 30% of the total worldwide installed server base. This is 3 to 10 million comatose servers potentially out there right now, just drawing energy. So again, I want to reiterate and congratulate all of the 2013 Server Roundup Award winners, AOL, TD Bank, Barclays, Sun Life Financial, and McKesson. I think you saw a lot of the details yesterday, but again, we're very excited that 15,000 servers were decommissioned. And again, our hope is that a lot of these are going to be replaced. Now that you have some infrastructure and some headroom, you have some electrical availability now that you can tap into in these data centers. So the question is, why is Samsung interested in eliminating these zombie or comatose servers? So think about, we're the largest memory supplier. Now put this in the context of what's happening inside a data center. IT equipment is about 56% of the total power consumption in a data center, and of that, roughly a third can be attributed to the memory components. Maybe 15% for the DRAM, maybe another 17% for the storage, either a hard drive or a solid state drive or SSD. And so with data center energy use doubling every 5 years, this is something that we're paying very close attention to as a memory supplier. So let's talk about the new SSD technology. You're talking about 80% less energy than a hard drive, 123 times faster from an IOPS perspective. It's kind of a no-brainer. So you put those two together, you're looking at up to 300 times more IOPS per watt. So it's not very often that some disruptive technology like this comes along, but this is, it truly is changing the way that data centers are built and operated moving forward. So let's look at an example of a solid state drive versus a hard drive power savings in a storage server. Because of that improved performance, you can actually reduce the drive count. This gives you wonderful TCO, or total cost of ownership, going from 120 drives down to 34, for example, in this case. That gives you about a 60% system level power reduction, and at the same time 4x increase in the number of IOPS. So again, this is why I think we're starting to see such a broad adoption of SSDs in data centers at this point. Looking at the DRAM for a second, the latest generation DRAM we have, which is on a 20 nanometer process node, is about 52% less power consumption than the lithography we had back in 2009. So in 2009, it was about 43 watts to light up 96 gigabytes of DRAM. Now we can do that with about 20 watts of electricity. So again, we have to be able to scale this in order to drive the continued need to build out these data centers without consuming inordinate amounts of power. Here's an example. This is a cold cache test that Microsoft ran, TPC-H, using a hard drive-based system with old legacy DRAM and a brand new solid-state-based system with cutting-edge DRAM. You can see on the hard drive case, it took about 2 hours and 45 minutes and used about 2,200 watts to perform this test, right? This cold cache test. The SSD-based system did it in about 11 minutes, 126 watts. So you're talking about 94% savings in power and almost 15x performance increase just by switching to the latest and greatest memory technology available. So let's take a look at some data center comparisons, legacy systems versus a green system. On the legacy side, again, 15K hard drive based, very fast RPM, produces a lot of heat, draws a lot of power. Right-hand side, we've got the green solution. A lot of SSDs in there, a couple of hard drives in there for some cold storage perhaps, and then the latest and greatest DRAM technology. Let's say we took a look at 1,000 units of these servers in say, a 5,000 square foot data center, maybe a typical average deployment nowadays. Running these two things in parallel, you see the differences, right? Server power, you're going to save about 18% in total power consumption. Your electricity costs are actually going to go down a little bit more than that because you have less cooling requirements because there's less heat being produced by the SSDs relative to the hard drives. And then lastly, maintenance, because of, again, the reliability, the predictability of those SSDs, much, much, much less in maintenance cost. We're estimating about 25% reduction on that. So the hypothesis then is, right now there's roughly 33 million servers on the worldwide install base. And depending on who you talk to and what that refresh is, it could be a little bit higher, it could be a little bit lower. We use a number of 33 million. The question is, if you replaced every single one of those servers, just the memory inside them, take out the old DRAM, put in the latest and greatest DRAM, take out all those hard drives, put the latest SSD technologies into these, what does that do? Saves about 5.6 trillion watt hours per year, which is the same as about 4 million tons of CO2, equivalent of planting about 100 million trees, or eliminating almost 1 million cars from the road. So again, you can see very, very disruptive just by replacing the memory inside. So I think the call to action for everyone in this room, I mean, we were very happy to be sponsoring this. We're very pleased with all the participation in this year's server roundup. The 15K number, I think, is a good starting point. Really, I think the call to action is how do we continue to shine a light on this? How do we work together as an IT community? Executives on the technology side as well as on the finance side have to be talking about this together to be decommissioning and replacing and optimizing a lot of these servers, especially those ones that are comatose. So again, I think the call to action is let's decommission and then hopefully replace another 100,000 zombie servers. So that is the end of my presentation. So I'd like to say thank you very much.